Have you ever wondered how the world of electronics came to be what it is today? Our journey begins in the late 19th century with the invention of the first electronic component, the vacuum tube. This device, initially used to control electric current in high-power radio transmitters, was a turning point in technological advancement. It paved the way for the birth of electronics as we know it. The vacuum tube, though bulky and power-hungry, was the precursor to the miniaturized and efficient devices that would follow. As we moved into the 20th century, another groundbreaking invention came into the picture, the transistor. Developed in 1947 by scientists at Bell Laboratories, the transistor was a game changer. It was smaller, required less power, and proved more reliable than the vacuum tube. This tiny device was the key to the rapid expansion of the electronics industry. Everything from radios to computers started to shrink in size, and technology began to permeate every corner of our lives. But the revolution did not stop there. In the late 50s, another significant development took place, the invention of the integrated circuit. This was the dawn of the digital era. An integrated circuit, or IC, is a set of electronic circuits on a small chip of semiconductor material. It allowed for even greater miniaturization and efficiency, paving the way for the creation of complex electronic devices and systems. From calculators to computers, from smartphones to satellites, integrated circuits are the backbone of the digital world. They have revolutionized industries, transformed societies, and reshaped the world as we know it. So there you have it, the dawn of electronics. From the humble vacuum tube to the complex ICs, the journey of electronics has been nothing short of extraordinary. In the next scene, we'll delve deeper into the branches of electronics and the formulas that power them. Stay tuned for a fascinating exploration into the heart of our digital world. Now that we have a brief history, let's delve into the different branches of electronics. The fascinating world of electronics is divided into three main branches: power electronics, digital electronics, and analog electronics. Each branch has its own unique focus, key formulas, and applications. Let's start with power electronics. This branch deals with the conversion and control of electrical power using electronic devices. The main focus of power electronics is designing and creating systems that efficiently convert alternating current, AC, to direct current, DC, or vice versa, and control the flow of electrical energy. The applications of power electronics are wide-ranging, from the power supplies in your computers to the systems controlling electric vehicles. The key components used in power electronics include diodes, transistors, and thyristors. The backbone of power electronics is Ohm's law, which states that the current through a conductor is directly proportional to the voltage across it and inversely proportional to its resistance. Next up is digital electronics. This branch is concerned with digital or discrete signals and the devices that process these signals. The primary focus of digital electronics is the design of circuits that use binary numbers for input, processing, transmission, storage, and display. The applications of digital electronics are ubiquitous in today's world, from your smartphones to the internet. The key components of digital electronics are logic gates, flip-flops, and microprocessors. Boolean algebra, which deals with binary variables and logic operations, is the fundamental concept in digital electronics. Last, but not least, is analog electronics. This branch deals with continuous signals and the devices that process these signals. The main focus of analog electronics is the design of systems that receive, amplify, and filter analog signals. The applications of analog electronics can be found in radio and television broadcasting, audio and video recording, and radar systems. The key components used in analog electronics are resistors, capacitors, inductors, and operational amplifiers. Kirchhoff's law, which includes Kirchhoff's current law and Kirchhoff's voltage law, is the bedrock of analog electronics. These laws help us understand how currents and voltages are distributed in electronic circuits. Each branch, with its own unique focus and key formulas, contributes to the vast expanse of the electronics field. These branches are not isolated, but rather, they intertwine and overlap in many areas, leading to the creation of hybrid systems. The beauty of electronics is in its diversity and the endless possibilities it offers, making it a truly captivating field of study and exploration. With a solid understanding of the history and branches of electronics, it's time to look to the future. A future that is as fascinating as it is challenging, with emerging trends like artificial intelligence, the Internet of Things, and quantum computing. Artificial intelligence, or AI, is no longer a thing of science fiction. It's here, it's real, and it's transforming the world of electronics. It's changing how we design and use devices, making them smarter, more intuitive, and more capable. We're talking about devices that can learn from their environment, adapt to user behavior, and even make decisions. That's the power of AI. Then there's the Internet of Things, or IoT, a concept that's turning everyday objects into smart devices by connecting them to the internet. Your fridge, your car, your watch, they're all becoming part of a vast interconnected network. And this network is set to grow exponentially in the coming years, with billions of devices joining the IoT revolution. This means more data, more connectivity, and more opportunities for innovation. But perhaps the most exciting development on the horizon is quantum computing. This technology operates on the principles of quantum mechanics, a field of physics that deals with phenomena on an incredibly small scale. Quantum computers promise to perform complex calculations at speeds that are currently unimaginable, opening up new possibilities for data analysis, cryptography, and problem solving. What does all this mean for the future of electronics? It means that the devices of tomorrow will be more powerful, more connected, and more intelligent than ever before. It means that we'll see new applications, new industries, and new challenges. It means that we'll need to adapt, to learn, and to innovate. The future of electronics is full of exciting possibilities with new technologies at the horizon, so let's embrace it, explore it, and shape it together. Let's take a moment to appreciate how these advancements in electronics have shaped our everyday lives. From the moment we wake up to the time we go to bed, electronics play a vital role in making our lives easier, more efficient, and more enjoyable. They're like silent assistants, working tirelessly in the background to make our day-to-day tasks seem effortless. Consider healthcare, for instance. The advent of electronic medical devices has revolutionized patient care. Pacemakers, insulin pumps, and digital thermometers are just a few examples of how electronics have improved the quality of life for millions of people around the world. In the realm of transportation, electronics have also made significant strides. The advent of electronic systems in vehicles has not only made driving more comfortable, but also safer. Features like GPS navigation, anti-lock braking systems, and airbag control units are all electronic interventions that have transformed our travel experiences. Then there's communication. Can you imagine a world without smartphones, laptops, or the internet? These electronic marvels have brought the world closer, breaking down geographical barriers and enabling instant communication across continents. And let's not forget entertainment. From high-definition televisions to gaming consoles, from music players to virtual reality headsets, electronics have redefined the way we relax, entertain ourselves, and interact with media. The impact of electronics extends even further, touching sectors like agriculture, where electronic devices assist in efficient farming, and education, where e-learning tools have made knowledge more accessible. Each of these examples underscores the profound influence electronics has on our everyday lives. The devices we often take for granted are the result of countless hours of research, development, and innovation in various branches of electronics. They've not only made our lives easier, but also more productive, more connected, and in many ways, more exciting. In conclusion, the role of electronics in our lives is not just significant, it's transformative. It has reshaped our world, turning what was once science fiction into reality. Electronics, with its various branches and advancements, has truly transformed the world we live in. As we wrap up our journey through the world of electronics, let's take a moment to reflect on what we've discovered. We started at the dawn of electronics, tracing its roots and significant developments. We explored the many branches of this vast field, each with its own unique formulas and applications. We then looked ahead to the future, where electronics promise to evolve in exciting and unimaginable ways. The impact of electronics on our everyday lives is undeniable. From the simplest gadgets to complex systems, Electronics are integral to our modern existence. They've transformed how we communicate, work, and enjoy our leisure time. In the grand scheme of things, we've only just scratched the surface of this intricate and ever-expanding field. There's so much more to learn, to explore, to invent. Before we sign off, remember to like, subscribe, and share this content if you found it informative and interesting. Stay tuned for more insights into the fascinating world of technology.